Early life and education. Dalton was born into a Quaker family of tradesmen. His grandfather Jonathan Dalton was a shoemaker, and his father, Joseph, was a weaver. Joseph married Deborah Greenup in 1755, herself from a prosperous local Quaker family. Dalton was the youngest of their three offspring who survived to adulthood. He attended John Fletcher's Quaker Grammar School in Eaglesfield. When John was only 12 years old, Fletcher turned the school over to John's older brother, Jonathan, who called upon the younger Dalton to assist him with teaching. 2 years later, the brothers purchased a school in Kendal, where they taught approximately 60 students, some of them boarders. As a teacher, Dalton drew upon the experiences of two important mentors, Elihu Robinson, a Quaker gentleman of some means and scientific tastes in Eaglesfield, and John Goff, a mathematical and classical scholar in Kendal. From these men John acquired the rudiments of mathematics, Greek, and Latin. Robinson and Goff were also amateur meteorologists in the Lake District, and from them Dalton gained practical knowledge in the construction and use of meteorologic instruments as well as instruction in keeping daily weather records. Dalton retained an avid interest in meteorologic measurement for the rest of his life. Early scientific career. In 1793, Dalton moved to Manchester to teach mathematics at a dissenting academy, the New College. He took with him the proof sheets of his first book, a collection of essays on meteorologic topics based on his own observations together with those of his friends John Goff and Peter Crostwood. This work, Meteorological Observations and Essays, was published in 1793. It created little stir at first, but contained original ideas that, together with Dalton's more developed articles, marked the transition of meteorology from a topic of general folklore to a serious scientific pursuit. Born and reared in England's mountainous Lake District, Dalton was well placed to observe various meteorologic phenomena. He upheld the view, against contemporary opinion, that the atmosphere was a physical mixture of approximately 80% nitrogen and 20% oxygen rather than being a specific compound of elements. He measured the capacity of the air to absorb water vapor and the variation of its partial pressure with temperature. He defined partial pressure in terms of a physical law whereby every constituent in a mixture of gases exerted the same pressure it would have if it had been the only gas present. One of Dalton's contemporaries, the British scientist John Frederick Daniel, later hailed him as the father of meteorology. Soon after his arrival at Manchester, Dalton was elected a member of the Manchester Literary and Philosophical Society. His first contribution to this society was a description of the defect he had discovered in his own and his brother's vision. This paper was the first publication on color blindness, which for some time thereafter was known as Daltonism. Atomic Theory of John Dalton. By far Dalton's most influential work in chemistry was his atomic theory. Attempts to trace precisely how Dalton developed this theory have proved futile. Even Dalton's own recollections on the subject are incomplete. He based his theory of partial pressures on the idea that only like atoms in a mixture of gases repel one another, whereas unlike atoms appear to react indifferently toward each other. This conceptualization explained why each gas in a mixture behaved independently. Although this view was later shown to be erroneous, it served a useful purpose in allowing him to abolish the idea, held by many previous atomists from the Greek philosopher Democritus to the 18th century mathematician and astronomer Ruggero Giuseppe Boscovich, that atoms of all kinds of matter are alike. Dalton claimed that atoms of different elements vary in size and mass, and indeed this claim is the cardinal feature of his atomic theory. His argument that each element had its own kind of atom was counterintuitive to those who believed that having so many different fundamental particles would destroy the simplicity of nature, but Dalton dismissed their objections as fanciful. Instead, he focused upon determining the relative masses of each different kind of atom, a process that could be accomplished, he claimed, only by considering the number of atoms of each element present in different chemical compounds. Although Dalton had taught chemistry for several years, he had not yet performed actual research in this field. In a memoir read to the Manchester Literary and Philosophical Society on October 21, 1803, he claimed, "An inquiry into the relative weights of the ultimate particles of bodies is a subject, as far as I know, entirely new. I have lately been prosecuting this inquiry with remarkable success. He described his method of measuring the masses of various elements, including hydrogen, oxygen, carbon, and nitrogen, according to the way they combined with fixed masses of each other. If such measurements were to be meaningful, the elements had to combine in fixed proportions. Dalton took the fixed proportions for granted, disregarding the contemporary controversy between French chemists Joseph-Louis Proust and Claude-Louis Berthollet over that very proposition. Dalton's measurements, crude as they were, allowed him to formulate the law of multiple proportions. When two elements form more than one compound, the masses of one element that combine with a fixed mass of the other are in a ratio of small whole numbers. Thus, taking the elements as A and B, various combinations between them naturally occur according to the mass ratios A, B equals X, Y, or X, 2Y, or 2X, Y, and so on. Different compounds were formed by combining atomic building blocks of different masses. As the Swedish chemist Jöns Jacob Berzelius wrote to Dalton, the law of multiple proportions is a mystery without the atomic theory. And Dalton provided the basis for this theory. The problem remained, however, that a knowledge of ratios was insufficient to determine the actual number of elemental atoms in each compound. For example, methane was found to contain twice as much hydrogen as ethylene. Following Dalton's rule of greatest simplicity, namely, that AB is the most likely combination for which he found a meretricious justification in the geometry of close-packed spheres, he assigned methane a combination of one carbon and two hydrogen atoms and ethylene a combination of one carbon and one hydrogen atom. This, we now know, is incorrect, for the methane molecule is chemically symbolized as CH4 and the ethylene molecule as C2H4. Nevertheless, Dalton's atomic theory triumphed over its weaknesses because his foundational argument was correct. However, overcoming the defects of Dalton's theory was a gradual process, finalized in 1858 only after the Italian chemist Stanislao Cannizzaro pointed out the utility of Amedeo Avogadro's hypothesis in determining molecular masses. Since then, chemists have shown the theory of Daltonian atomism to be a key factor underlying further advances in their field. Organic chemistry in particular progressed rapidly once Dalton's theory gained acceptance. Dalton's atomic theory earned him the sobriquet Father of Chemistry. Later years. After the age of 50, Dalton performed little scientific work of distinction, although he continued to pursue research in various fields. When faced with the Royal Society's rejection of his 1838 paper on the arseniates and phosphates, he had it printed privately, noting bitterly that Britain's chemistry elites, Cavendish, Davy, Wollaston, and Gilbert, are no more. His atomic theory eventually began to prove its worth, and its author gained widespread recognition. He was elected into the Fellowship of the Royal Society of London and the Royal Society of Edinburgh, awarded an honorary degree from the University of Oxford, and elected as one of only 8 foreign associates of the French Academy of Sciences, taking the place vacated by the death of Sir Humphrey Davy. He also received a pension on the Civil List from the British Crown. In Manchester he was elected president of the Literary and Philosophical Society in 1817, continuing in that office for the rest of his life. The society provided him with a laboratory after the new college moved to York. Dalton remained in Manchester and taught private pupils. Despite his growing affluence and influence, his frugality persisted. He died of a stroke and was accorded the equivalent of a state funeral by his fellow townsmen.